Welcome back to another MECH 1000 video. We are looking at Unit 7 in the Blueprint Reading textbook and answering some questions about drawings that have been dimensioned with limits, or converting our typical tolerances to limits, or the other way around. So here we have this drawing of a soft jaw, and we have a dimension on here. Here it is. That is dimensioned with limits. It gives us the maximum and minimum allowable sizes of 0.750 and 0.748, and we want to replace that with a single dimension with a bilateral tolerance. So we want some dimension plus or minus some tolerance amount. So we need to find the average of the two values and put it right there. So the average between 0.748 and 0.750 would be 0.749, and then the tolerance amount would be, if we take the difference between these two, 0.750 minus 0.748 is 0.002, and then divide that amount into, we would get 0.001. So 0.749 plus 0.001 gives us the 0.750, and 0.749 minus 0.001 gives us 0.748. So this is the dimension with the bilateral tolerance. So bilateral means in both directions, plus and minus. And this is limits. Okay, sometimes, and this is a new topic we're moving on to here, sometimes you might have a drawing where there's a large amount of detail in a small area, and the drawing is really too crowded, or just doesn't clearly show what is going on in that particular area. But if it's just a small portion of the drawing, you may not want to increase the scale of the entire drawing. That may unnecessarily make the drawing bigger than it needs to be. So you might just want to take part of that drawing and blow it up to a bigger scale so that it can be seen in more detail. And that would be what we call a partial enlarged view. So for example, here we have the drawing of this clevis pin, and we might want to look at this little area in slightly more detail so we can see the depth and the radius and things like that. So that little part has a circle around it with the letter A next to it. And then off to the side, we have view A, and it is shown at a larger scale. This is a 2:1 scale, where the rest of the drawing is at a 1:1 scale. And so let's answer a few questions about this clevis pin drawing. What is the smallest acceptable radius under the head? So this is a bit of a trick question here. So the note here tells us that it is a 0.015 radius, but it's a maximum. So it can't be any bigger than that. And the question is asking, what is the smallest? So this is a single limit. It's unilateral. It's not telling us what the smallest it can be. It can be as small as physically possible, which means that the smallest it can be is 0. The largest it can be is 0.015, but that's not what the question is asking for. The question is asking for the smallest, and the smallest it could be would be to have no radius at all, for that to be a sharp corner with no radius at all. So get rid of that radius, and what you have left is a sharp corner, which has a radius of 0. Okay, we're getting close to the end here. This is one of the last topics, I believe, in this unit. Sometimes it may appear when you're looking at a drawing that it might be missing a dimension, or it may seem like you can't find a particular dimension, and that might be because the dimension is implied by the stock material that the part is made out of. For instance, if you were looking at a gasket made out of sheet metal or some type of sheet of plastic, and the thickness of that stock material is listed in the title block, that dimension may not appear in the drawing itself. Or if the part is turned on a lathe and made from hex bar size, that is a stock size, the overall width of it may not be specified on the drawing. Instead, it may be found in the title block because it is the size of the stock material that was made to make that part. Knurling is a type of surface treatment where ridges are scored or cut in a pattern onto the surface. The purpose of this is typically to provide a better grip or to increase the friction. So it's used oftentimes in handles, like dumbbell or barbell handles often have a diamond pattern on them. That diamond pattern is an example of knurling. Knurling can also be just parallel straight lines. And graphically in a drawing, you can represent the pattern with a hatch pattern in AutoCAD, or you can not visually represent it, but instead just describe the knurl pattern in a local note. Heat treating notes are something that we don't need to spend a lot of time on. I know the textbook has quite a bit of information on different metals and different hardness and different things that can be achieved by heat treating. We don't really need to know a lot of that in great detail. There may be some other classes in the mechanical curriculum if you're a mechanical engineering technology student in which you will learn more about heat treating and hardness and other material properties like that. But in this class, we basically just need to recognize some of the terminology. So an example of that would be a Rockwell number. A Rockwell number is information related to the hardness of the metal in used to make a part. So if you are looking at a print of a technical drawing and you're asked what its hardness is, what you may be looking for is some information on the drawing somewhere that indicates what the Rockwell number is. So if we look at this last example problem, some of these questions will illustrate some of the topics I just introduced. So what is the stock cutoff length? So we have here this center punch that we're going to make. We're going to cut a stock piece of material from some round bar stock, and then we're going to probably turn down on a lathe to get this shape. And so the question here is what is the size of the stock material that we start with? We can see that when the part is finished, it's going to have, it looks like a maximum diameter of 0.44 and a length of 5.25. But we're going to start with the stock material. It can be seen down here in the title block, 0.500 diameter. So it's made from 1/2 inch diameter steel round bar stock, and we're going to cut it to a 5.5 inch length in order to make this center punch. What style of knurl is specified? We can see the knurl pattern indicated here and the local note that says 96 DP diamond knurl. So it's a diamond knurl pattern. And finally, what are the limits of the hardness? So the RC number here is the Rockwell C hardness number. It indicates that the hardness needs to be somewhere between a 35 and a 40. Again, we're not really going to emphasize what that means. We're not really getting into material properties in this particular class. We just need to be able to read and recognize that information on a drawing. So that brings us to the end of Unit 7 in our blueprint reading textbook. As always, if you have any questions, feel free to use the discussion board or email your instructor or just simply ask a question in class.